Good morning guys and welcome to Mind Your Math. Today we are doing the chapter surface area and volume, and this is basically about finding out the surface area and volume of three-dimensional figures. So from two-dimensional figures like circles, squares, rectangles, etc., whose area we used to find, we are now moving on to three-dimensional figures, and because they are three-dimensional, we are also concerned about their volume. So here we will be learning about cube and cuboid, sphere, cone and cylinder. In your textbook, the surface area part is covered first and then the volume. But here I will be doing surface area and volume of a particular shape first. So we will be moving in accordance with the shape and finishing off the area and the volume one by one. Okay. Now, if you have any doubts regarding the contents of this video, please mail me at the mail ID given below in the description box. Okay, so now let us start with cube and cuboid. So we will first go through the basic terms and the basic definitions of a cube and cuboid, and then we will move on to the area part of it and then the volume. Okay. We start with cuboid. Now, cuboid and cube both are very familiar shapes to you, especially the cube. You definitely must have, every one of you must have played with the Rubik's cube. That is a proper example of a cube. So we will get down to the mathematical definition of a cuboid. A cuboid is a solid figure which is bound by 6 rectangular faces. So I have made a diagram over here and it pretty much looks like a cuboid. So we can see that there are 6 rectangular faces. So you have a bottom face, a top face and 4 side faces. These 4 side faces are called as lateral faces. So depending upon how the cuboid is placed, any face can be the base face or the bottom face. So this face is called as the base. This is called as the top. The remaining 4 faces are called as the lateral faces. Okay. Now you can see that since all the 4 are rectangles, the cuboid has got a length, a breadth and a depth or a height. So it has got a length, a breadth and a height. Okay. And 2 faces meet together and form a line over here which is called as the edge. Okay. And 1 edge, 2 edge and 3 edge. 3 edges meet together to form a vertex. So, how many vertex does a cuboid have? 1 here, 1 here, 1 here and 1 here, and similarly on the back. A cuboid has got 8 vertices. Okay, so it has got a length, breadth and height. All the faces are rectangular faces. The point where 3 edges meet is called as a vertex. A cuboid has got 8 vertices. So depending upon how a cuboid is placed, any face can become the base. The remaining faces are called as lateral faces, and you have a top face also. Now if you have an open cuboid, we will not consider the top face at all. If you have an open cuboid, we will not take the top face into consideration at all. We will have the base and we will have the lateral faces. Okay, so now we are done with the definition and the basic understanding of the cuboid. We will see what a cube is. A cube is a cuboid whose all sides are equal, or basically all the faces of a cube becomes a square. The remaining definitions practically remain the same, but except the fact that instead of rectangular faces, we have square faces. That solid shape is called as a cube. Look at your Rubik's cube, you can get a very clear understanding of what I mean. Okay. Now, when we are talking about cuboid, the cuboid can be a hollow cuboid, or cuboid can be a cuboid which is filled with something. So they will mention it in the question. So if it is filled with sand or if it is filled with water, whatever it is, they will mention it in the question. Otherwise, take it that it is a hollow cuboid and proceed with the sum. Okay. Now let us move on to the first part, which is surface area of a cuboid and that of a cube. We have a cuboid here, and you know the faces are all rectangular. Now I said a cuboid has got length, breadth and height. Now if this is our cuboid, and if we take this as the length of the cuboid, this as the breadth of the cuboid, and this as the height of the cuboid. Okay. Now you know that there are 6 rectangular faces. So what is the area of the face facing us? It is L into H. That will be also the area of the face which is I have marked with the pink colored pen. So that also will be L into H. Okay. These two faces will be B into H. Those are the faces on the side. So how many B into H is there? 2. Then we have a top face and a bottom face whose area is given by L into B. So what can you say about the total surface area of a cuboid? It's the sum of all the areas. So it is 2 into LB plus BH plus LH. Now, though this is the total surface area of the cuboid, you should know how to differentiate between the base area, the top area and the lateral surface area. So, how many lateral faces are there? I have a face here. Correspondingly, I have a face there. Its area is given by B into H. Okay? Okay. Now, I have got a face behind whose area is given by L into H. The top face is given by L into B. So, the lateral surface area of a cuboid is given by 2 into, so looking from the diagram, you can make out which is the lateral face. So, we can say that the lateral face area is equal to 2 into LH plus BH. And the bottom and the top area will be 2 into LB. So, you know how to differentiate between TSA and LSA, which is the total surface area and the lateral surface area. TSA is LSA plus bottom area plus top area, and you know how to find the LSA. Okay. Let us see what is the formula for the diagonal of a cuboid. Now the diagonal of a rectangle is given by, what is it given by? If this is L and this is B, we will be getting L square plus B square under the root. Okay. In the case of a cuboid, the diagonal is given by L square plus B square plus H square under the root. Okay. Now, there is one more formula which you don't really need to remember it as a formula. By basic logic, you can understand what is the sum of all the edges of a cuboid. How many edges does a cuboid have? This is the best example that I could take for a cuboid right now. A book. You have the top face, you have the bottom face, you have 1, 2, 3 and 4 lateral faces. 6 faces. We will count the number of edges. I said the bottom face has got 4 edges, which I showed by this rectangle. Okay, the black one. So I have got 1, 2, 3 and a 4 over here. Okay. Similarly, I have got 4 on the top also. This 4 on the top and 4 on the bottom. Both surfaces are joined together by these edges. So I have got 12 edges in total. Okay. Now, the top face has got 2 length. Sorry, the top face has got length. Here there is an L. Here there is an L. Similarly, bottom also I have got 1 L over here and 1 L in the back also. So I have got 4 length. Now let us see how many breadth I have got. Here 1. Here 1. Similarly, the bottom face also got 2 more. So I have got 4 breadth also. Now let us see how many height I have got. Here 1, and the side faces has got 2 to each. So I have got 4 height also. Okay. So see, even if you look around your room, you pick up any book and you will understand that it's in the shape of a cuboid and you can use it to understand how to find the area. Now, whenever I am talking about area, I always, because sometimes the students get confused as to in some cases, you know, there is a curve in the solid or something like that. They will immediately get confused whether I should include that also as the area. Whenever you are finding the area of a solid, the place where you can run your hand or you can feel the surface of the solid, you can just imagine it, right? When you have a solid and it has this particular shape, can I put my hand over it? Can I feel the shape or can I feel the surface? That part has to be accounted for area. In the case of this particular cuboid, if I need to find the area, here I can run my hand, here I can run my hand, here I can run my hand, here. All those places will be accounted for area when we are trying to find the TSA of a solid. Okay, always remember it. Area is basically all the areas or all the spaces where we can feel with your hand. Okay. Now let us talk about the area of a cube. Now that you know the area of a cuboid, it is pretty much easy. A cube has got how many faces? A cube has got 6 faces. All the faces are squares, thankfully. Area of one face is a square. Multiply it by 6 in order to get the TSA. Now, for lateral faces, LSA will be 4a square. The base area will be a square, the top area will be a square. So, the sum total will be 4a square plus a square plus a square, which is 6a square. Okay. Now, what is the diagonal of a cube? The diagonal of a cuboid is given by L square plus B square plus H square. In the case of under the root, in the case of a cube, all these lengths are equal. So, I will take all the length to be equal to L. So, I will get root 3L. Okay. Now, how many edges? You know 12 edges. All the edges are equal. So, 12 times the length of one edge will give you the length of all the edges. Now, we have gone through all the basic formulas for the surface area of a cube and a cuboid. Now, let us do a few sums and see how actually this formula is applied. Okay. So, I have written down 4 sums. So, let us tackle them one by one. A chalk box of length, breadth and height being 16 centimeter, 8 centimeter and 6 centimeter, we need to find the total surface area. Now, you know that a chalk box, because all the 3 different length measurements are given to you, it has to be a cuboid. Now, what is the surface area of a cuboid? Surface area of a cuboid is given by 2 into LB plus BH plus LH. Okay. Now, I have got 2 into 16 into 8 plus 8 into 6 plus 16 into 6. It's basic calculation and very direct formula. So, I am taking it for granted that you people will be able to do this calculation and get the answer. It is a direct application of the formula. Now, let us see how the second one is done. You have to find the surface area of a cube whose side is 11 centimeters. So, whenever in the question they say surface area, they mean the TSA unless it is specifically mentioned to you. Even if they do not say total surface area, you have to assume that it is total surface area unless they have told you that find the lateral surface area or find the area for covering the lateral faces, etc. etc. So, here we have to find the surface area of a cube whose side is 11 centimeter. You know what is the surface area of a cube? It is 6a square. So, 6 into 11 square. 6 into 121, get the answer. Okay. Now, these are all direct. These two were direct application of the 2 formulas. Now, let us check the third one. A plastic box of 1.5 meter long, 1.25 meter wide and 65 centimeter deep is to be made. It is to be made open at the top. Find the area of the sheet required for the box. Now, we need to make a box which is in the shape of a cuboid, but the top part is open, which means that the top surface is not there. Okay, so we have to discount the area of that particular part. So now let us see how this is done. I think this is an NCERT sum. I think it's the first sum in the NCERT book. I'm not very sure about it. Anyways, let us get on with the sum. So this is our cuboid, and we know that we don't have to take into account the area of this particular part because the box is said to be open. Now, what is the area of that particular part? The area of that particular part is L into B. When they are saying deep, it means the height, the width means the breadth. Okay, so when you are drawing the diagram or taking the measurements, please be clear with it. So, we do not have to take one L into B into consideration. So, the remaining formula remains the same. It is 2 into LH plus BH plus 1 LB. So, here I have written down the steps for doing this particular sum. You can see that the length is 1.5 meters, breadth or the width I have written to be 1.25 meter and height or the depth is 65 centimeter. Now, one of the main points that you need to remember in this particular chapter are the units. Sometimes they mix up the units and give, like in this sum, some of the measurements are given in meters, one is given in centimeter. So, if you are not very careful, what happens is that you will be continuing with the same unit across the sum without paying attention to what is actually given. Here we need to convert the centimeters into meters, or if you want to convert all the meter measurements into centimeter, that is also absolutely fine. Okay. Now, 65 centimeter, I have converted into 0.65 meters. The total surface area is given this. This is L into B. Only one L into B is taken into consideration. I am getting 5.45 meters square. I have used a calculator for solving this sum, but you people definitely cannot be using a calculator. So it is always better that you guys get faster with the calculations. That can only happen if you do the sums without using a calculator or without any other external help. Okay, do the calculations properly using a pen and a paper. Only then you will have the necessary speed to complete the calculations correctly during the examination. Now, second part is you have to find the cost of the sheet that is required. 1 meter square cost 20 rupees. So 5.45 meter square cost 109 rupees. So in this particular chapter especially, please be careful about the unit and converting one unit into the other and writing down the proper unit after finishing the sum. Okay. Let's have a look at the fourth sum. 3 cubes are joined end to end. If the side measures 5 centimeters, find the surface area. So we have to find the TSA of the resulting solid. Now, 3 cubes, they are joined end to end. So, this side is being joined to this side. This side is being joined to this side. So, finally, we are having a shape something like this. Here we have 2 divisions. I mean, like it has been joined. Now, the resulting solid that we are getting is a cuboid. Okay, you can see very clearly it is a cuboid. What will be the length of the cuboid? The length of the cuboid will be the length of this plus the length of this plus the length of this. Correct. So each side measures 5 centimeter. The resulting cuboid will measure, the length has 15 centimeters. Okay. Now, though because they are cubes and all the sides measure 5 centimeters, what will be the depth? The depth will be the same as this. So this is 5. And what will be the height? This will again be 5. So what will be the TSA of the resulting cuboid? It will be 2 into LB plus BH plus LH. So let us see what we are getting. 2 into 30, sorry, my bad. 75 plus 25 plus 75. Or I will get 2 into 175 or I will get 350 centimeter square. Let us have a look at another way of doing this particular sum. So you know that we got the answer as 350 centimeters square. You know that this is a cube, this is another cube and this is another cube. So when all these 3 cubes are joined, you know that what cube will be sandwiched in between. Suppose this is a cube. Okay, it is not exactly a cube. Suppose this is a cube. I am attaching one more cube similar to this. What happens? I told you that area is found out by the space over which we can run our hand. When I am having an individual cube, I can run my hand all over. So it is 6a square, all the faces. But when I am attaching one more cube over here, what happens? After attaching, I cannot put my hand over here because another face is stuck to it. Okay. So that face from this particular cube is gone. Similarly, that face from the second cube is also gone because it is attached over here. I cannot put my hand over there. Correct. Similarly, look at this particular cube. The normal area would have been 6a square. Because I am attaching another cube over here, this face area is gone. So I end up with only a 5a square. Look at my second cube. Because I am attaching this face over here and this face to the face of the third one, I am losing 2 faces over here. So I end up with what? 4a square. What happened to the third one? The third one is also like the first one, it has lost 1 face area. So it is again 5a square. So what do I get? I get 14a square, which is 14 into 5 into 5, 14 into 25, 350 centimeters square. This is another way in which you can do this particular sum. You can either opt for, finding out the final shape and then calculating, or you can use this logic. But then if you are using this logic, you have to explain very clearly in your answer why you are losing 1 face and the remaining part of it. Okay. One of the very common sums that you get in surface area, especially when you are dealing with a cuboid, is painting a room. Painting the walls of a room. Sometimes they include the ceiling. Sometimes they don't include the ceiling. Sometimes they ask you to tile the floor, cement the floor, whatever. Okay. Now, all those questions I will club under one particular concept of painting the room, so they can deal with any kind of questions that come under that. Okay. So whenever they give the dimensions of a room, they obviously has to give you length, breadth and height, or they have to give some relation between the length, breadth and height. Length they will give, breadth is like half of this or twice of that, something like that. Okay. So you can figure out the length, breadth and height. Now after that, they will ask you what is the cost of painting the four walls of a room. They will ask you what's the cost of painting the four walls of a room and the ceiling. So you should know which is the area that you should be taking in order to find out the cost that they have asked in the particular question. So you know that the room is in the shape of a cuboid. Don't mind my diagram at all. And this is a person who is standing in the room. Okay. So this is the floor, obviously, where the person is standing. The place where the person can't reach, extend the hand, is this, which is our ceiling. Then you have got one wall, two wall, three wall and the four wall. Okay. And whenever they give you, they see one more twist in the question that can happen is that they will give you a wall and then they will say that there is a door a size of so and so. You don't have to consider the area of the door. You have to consider the area of the door. So let us paint the area in it. Let us paint the door in a different color. Then what is the total cost? Such complicated questions can definitely come. So let us break down all those concepts one by one. Okay. So let us go to the basic one where they are asking you to paint the four walls of a room. Okay. So you can see that this is the length of the room. This is the width or the breadth of the room and this is the height of the room. Now, the first thing that we will deal with, let us break down the areas into different parts. What is the area of the floor? Area of the floor is actually the area of the base where the person is standing. It is L into B. Okay. What is the area of ceiling? Area of the ceiling is same as the area of the floor. Otherwise, the room would look really weird. So that is again L into B. What is the area of the four walls? You can see from the diagram that it is B into H, one wall. The wall opposite side, B into H, plus you have the wall on the back of the person and on the front of the person whose area is given by L into H and L into H. So it is 2 into BH plus LH, which is our lateral surface area. Okay. Now I have broken down the area into area of the room into area of the floor, area of the ceiling and the four walls. If in the question they ask you to find out the cost of painting the walls, this is the area that you should take. Now guys, one thing you need to understand is that it is always better to understand the measurements that are given to you and then take out the measurements that you require rather than by hearting this. Now the reason why I am telling you no to by heart is because they can always tell that there is a window on one of the walls. Then you don't get confused as to which area you should take, how many times I should take the value of BH or how many times I should take the value of LH, where should I subtract it from, etc. etc. So whenever you are giving a sum based on the room, this is the diagram that you should draw minus the person obviously and then write down the area that you need actually. In the question, suppose they are telling you, what is the cost of painting the ceiling, let us say with a blue color paint, okay, and they are telling that the cost of painting is, let us say, 100 rupees per meter square, some design, whatever, okay. They are asking you for the ceiling. Now, the ceiling is the same as that of the base, which is L into B. So you need to find the product of L and the product of B, which is 20 meters square. That is the area of our ceiling into the cost. Okay. So always understand the values that are given to you, the room that you are in or the room that they give in the question and then apply it. Okay. Now I'll give you an examples we will do a few examples based on this kind of concept and let us see how complicated it can become and how to solve them. The first one, All the three are direct ones. So first let us go through that first and then we will move on to a little complicated ones. You have to find the cost of painting the walls at rupees 20 meters square. So you know the 4 walls of the room, the area is given by B into H, 2B into H, and the front part is given by L into H. So 2 into BH plus LH is what we need to find, and that will give you the area of the 4 walls. After finding out the area of the 4 walls using this, you need to multiply it by 20. Okay, so let us do it. The area will be given by 2 into, this is our B also, 4 into 3, 12, BH plus LH is 5 into 3, 15. This will give our area into 20. Okay. Now we need to find the cost of painting the ceiling at 25 meters square. I told you the area of the ceiling and area of the floor, they both are the same. So it is L into B. So finding out the area of the ceiling will be finding out L into B. There is only one L into B because we are only taking the area of the ceiling. So that into 25. So it will be 5 into 4 into 25. Okay. We need to find the cost of cementing the floor at rupees 20 meters square. The area of the floor is again L into B. Only once you have to take because only the floor you are taking, L into B into 20. Let us have a look at the sum. A room has the following dimensions. Length, width and height is given to you. There is a huge painting of size 9 meter into 4 meter on one wall. Find the cost of painting that wall with blue paint at rupees 100. Find the cost of painting the other 3 walls at rupees 50 with white paint. So I have drawn the cuboid here. Our room is in the shape of a cuboid. Now, what I have done is that because there is a painting on one wall and they have not mentioned which wall that is, the painting is put on which wall, I have broken down the area of the room into separate parts. So, this is my room, this is my length, this is my breadth and this is my height. Okay. Area of the floor and area of the ceiling is not coming into the picture in this particular sum. They have not mentioned anything about the floor and the ceiling. But my floor area and the ceiling area I have anyway written down. This is my length and this is my breadth. So my floor area is 10 into 6. I have got the ceiling area also is 10 into 6. Let it be there. Okay. I have got 4 walls. There is a front wall which is this, whose length is 10 and whose height is 8. Okay. So I have got 10 into 8. The back wall also has the same area. Okay. There is a side wall of this area which is 6 into 8. Okay. So side wall 1 6 into 8, side wall 2 6 into 8. Now out of these 4 walls, one wall has got a painting which measures 9 meter into 4 meter. They have not mentioned which wall. You can see that there is no way you can put a painting which is measuring 9 meter into 4 meter on the side walls. I can only put the painting either on the front wall or on the back wall. But thankfully, since both are of the same area, it doesn't matter at all. Okay. So I will assume that one of these walls has got this painting. Let it be the front wall or the back wall. Let us see. We will reduce the area of the painting as and when we proceed with the sum. But we know from which area we need to reduce. Now we need to find the cost of painting that wall with a blue paint at rupees 100 per meter square. So the painting is put in a wall which is measuring 10 into 8, which is 80. From that one wall, whether it be the back wall or the front wall, doesn't matter, that from that particular wall, 36 meter square has to be subtracted. So the cost of the remaining wall is 36 meter square. So what do I get? I get 44 meter square. After putting the painting on that wall, I am getting only 44 meter square area for actually painting that wall. Okay. So multiply it by 100. 4,400 rupees is the area that we need to spend for painting that particular wall. Okay. Now they are asking what is the cost of painting the other 3 walls. So other 3 walls, I have got a front wall, I have got 2 side walls. So I have got a 48, I have got a 48, I have got an 80. So it is 80 plus 48 plus 48 is the total area that I need to paint with white paint at the rate of rupees 50. That you know how to find the area, multiply it by 50. Okay. So I hope you understand why it is very important to segregate the areas inside your head. Just by hearting the formula will not work, because you need to know from which area you need to reduce what. Okay, I hope I have given you a clear idea about how to break up a room into its component areas. The sum of length, breadth and depth of a cuboid is 19 centimeter and the length of the diagonal is 11 centimeter. Find the surface area. In this particular question, you can see that the value of length, breadth and the height of the cuboid is not separately given to you. Instead of that, there is a link between all the three measurements that are given to you. One is that L plus B plus H is 19 and root of L square plus B square plus H square is equal to 11, which is the diagonal length. From these two values, we need to take out the values that we need to find out the total surface area of a cuboid. So either we need to find out the values of length, breadth and height separately, or we need to manipulate our formula in such a way that we get the desired value from these two statements. Now, let us see what are the values that we can find from these two. Okay. So, from this statement, I can write L square plus B square plus H square is equal to 121. I am squaring both the sides. If I square L plus B plus H the whole square, I will be getting 19 square. Right? What is this equal to? L square plus B square plus H square plus 2 into LB plus BH plus LH. Okay. What is the value of L square plus B square plus H square equal to? It is 121 over here. Right? You will get 2 into LB plus PH plus LH is equal to 240. So, from the two formula, or from the two statements that were given to you, we were able to segregate the value of this. You know that this is the formula for the TSA of a cuboid. So, we have directly gotten the value of the TSA without separating L, B and H. Okay. Now, what is the basic formula that we will be getting from this particular sum? So, L plus B plus H the whole square is equal to L square plus B square plus H square plus 2 into this value. Now, this is our TSA. Total surface area. This is diagonal square. So, we can say that L plus B plus H the whole square is equal to diagonal square plus the total surface area. Now, it is just an outcome of this particular sum, and see, there is not exactly a need to memorize this particular formula because it is easily derivable from the existing data that is given to you. But in case you want to, do not want to waste your time by doing this and then squaring it and all that, you can always remember this formula and apply it directly when you get the sum. Okay. This particular sum I have taken from R.D. Sharma. Actually, most of the sums I have done in this particular video, I have taken from either R.D. Sharma or from NCERT. So, let us have a look at this sum. So, length of a classroom is 2 times the height and the breadth is 1.5 times the height. The cost of whitewashing the walls at the rate of 1.60 is rupees 179.2. Find the cost of tiling the floor at the rate of so and so. So, read the question properly always. I don't have to repeat it every single time I am doing a particular sum. I am taking it for granted that you guys will read the question properly and write down the data properly. Okay. Now, here the length of the classroom is 2 times the height. So, which means that the values are not separately given to you. Again, a relation is given to you, but this time the relation is between the length and the height and then the breadth and the height. So, if you denote length, breadth and height by LBH, length is given as 2h and breadth is given as 3 by 2h. Right. Now, the cost of whitewashing the walls at the rate of 1.60 is 179.20. So, this is a room which is in the shape of a cuboid, right? So, I have got L, B and H. Now, the walls means the ceiling and which is the ceiling and the base, they are excluded. So, L into B is not there in the picture at all. So, what is given to you? 2 into LH plus BH is the area of the 4 walls of the room that multiplied with the rate of painting will give me 179.20. Okay. Now, 2 into LH plus BH is equal to 179.20 by 1.60. Okay, I get 112. So I am getting 2 into LH plus BH is 112. What is it that I need to find? I need to find the cost of tiling the floor. So what is the floor area? Floor area is L into B. So I need to segregate L into B from this, so which is not possible unless I separate L, B and H value. Okay. So what will we do now? We will get LH plus BH is equal to 56 from this statement. Okay. H is a common factor. Right. Now, what is the value of length in terms of H? It is 2H and the breadth is 3 by 2H. This is equal to 56. Okay. So, H into 7 by 2H is equal to 56, or I can say that H square is equal to 56 into 2 by 7. Right. So, 112 by 7. So, I will get the value as 16. If I am taking the square root, I will get plus or minus 4. Minus for a negative value for any measurement is not possible. So, the value is plus 4. So, I can say that the height of the room is 4 meters. Because the height of the room is 4 meters, what is the length of the room? It is 8 meters. And what is the breadth of the room? It is 3 by 2 into 4, 6 meters. So I have gotten the value of length, I have gotten the value of breadth, and I have gotten the value of height, all three of them separately. Now, how do I find the value of area of the floor? It is L into B. So, L into B becomes 8 into 6, which is 48 meters square. I have gotten the value of the floor area. What is the cost of tiling? Area into 6.75. Then we will get the total cost of tiling the floor. I hope you are clear with the sum. Here the length and the breadth were given in terms of height. And the cost of whitewashing the walls were given to you, which is 2 into LH plus BH into the rate of whitewashing the floor is giving you the total cost. Now, I have gotten the value of LH plus BH as 56. In order to segregate them, I have used this relation. I have written down L and B in terms of H. I have solved for H and then found out the values of L and B and applied in the formula for finding out the area and then the cost. Okay, I hope this sum is clear to you. So, we are winding up the class on the surface area of cube and cuboid. Now, we will be doing the volume of cube and cuboid. I hope you are pretty clear with this particular concept. It's an easy concept, except that you need a clear idea about the area that you need to find and to how to segregate the measurements. Okay. In some cases, it will be directly given to you, value of length, breadth and height. Sometimes a relation is given to you from which we have to figure out what is to be applied in the formula, etc. etc. We will wind up this class with the sum that is given in the NCERT textbook. Actually, it is an optional sum, but then I found it very interesting and it is a very good way of applying, your logic on as to what to find when you are finding the area of a cuboid or a cube for that matter. Okay. A wooden bookshelf has the external dimensions as follows. Height, depth and breadth, they are given to you. The thickness of the plank is 5 cm everywhere. External faces are to be polished and the inner faces are to be painted. The rate of polishing is 20 pies per centimeter square and the rate of painting is 10 pies per centimeter square. We need to find the total cost. I hope I have not made a mess of the whole diagram. I have tried to reproduce it in the best possible way that I can. But as long as you get the measurements correctly, I don't think it matters. So now let us get down to the sum. So the height, depth and the breadth is given to you, which are the external measurements. Now our problem lies in the fact that there is a thickness that is given to you. So let us mark the dimensions and see how best we can take out the dimensions and to proceed with the sum. So here you know that the external faces are to be polished and the inner faces are to be painted. So let us first find the area of the external face. Now when I am talking about the area of the external face, I know that I have a top face here. Okay. I have a side face here. Similarly, I will have a side face on that side also. Correct. I have a bottom face over here. And because it is a bookshelf, there has to be a back side also. So I have a back like a back wall or a back face over there. Okay, these are the various parts, external parts whose area I need to find. Now what are the measurements that are given to me? It is given that the height is 110 centimeters. So I know that this value is 110. Right? Depth is 25. Now breadth is 85. Okay. Now this is 85. I know this is also 85. Correct? This is 25. I know this part is also 25. This is 110. I know this side is also 110. This side is also 110. This is also 110. I am not marking it. Okay. Now, the top face. What is the area of the top face? I can see that the top face has a length of 85 and a breadth of 25. The top face has an area of 85 into 25. Right. Bottom face also has an area of 85 into 25. The side face has a breadth of 25 and a height of 110. So the side face 1 and the side face 2 both has an area of 110 into 25. Because there are two faces, I multiply it by 2. Right? Now I have got a back face, something like this itself, whose length is 85 and the height is 110. Now, sorry, I have gotten the area of all the faces. Now, is our external area over? The front side, though the full area is open, you can see that, see, this part is open. It's a shelf area which is open. This is a shelf area which is open. This is a shelf area which is open. No need for polishing. But we know that there is a small wooden plank that goes all around, which is of thickness 5 centimeters. So I can say that this is 5 and I can say that this is 5. Everywhere it is 5. We need to find out the area of that wooden part also, because that is a part that is need to be polished. Okay. So here you have a rectangle. The rectangle is of height 110 and width 5. Okay. So I get an area of 110 into 5. Okay. The same kind of rectangle is on this side also. So 2. Okay. Now plus. Once the rectangle is gone, I have another rectangle like this, whose breadth is 5. What is the length? The total length is 85. 5 thickness is gone here. 5 thickness is gone here. So remaining I have got 75. Okay. Now I have got a similar one over here. I have got a similar one over here, and I have got a similar one over here. So in total, how many do I have? I have got 4 horizontal thick planks. So it is into 4. Now I have taken into account all the external dimensions. So let us find out the total area by adding up all this. I have written down the area, which means the external faces area. I have written down separately the top face plus the bottom face, because both of them have the same area. I have written it over here. The side face, the two side faces have an area of 110 into 25 into 2. This. The back face. Now I have written the area of the wooden plank. So 2 into 110 into 5 is the area for this plank, and the horizontal planks are 4, whose area is 1500. When you add up all these areas, you will get 21,700 and multiply it by the cost in order to get the total cost. So I have written it very clearly. So this is the external cost for polishing the wooden shelf. Now we will need to, we need to find the cost of painting the inner faces. Okay, so I hope you are clear with the external area. Now let us calculate the area of the inner faces that are to be painted. When you look at the diagram, the inner face is the inner face of the shelf. That shelf area is in the form of a cuboid. So Okay, this one is exactly in the shape of a cuboid. Now we need to find the length, breadth and the height. You know that this length is the total length minus the width on the two sides. So the length is 75. Okay. Now we need to find out the breadth. It is 25 is the external. So in the front you also have the thickness of the wooden plank. So it is only on one side. It is there, not there on the back side. So when you subtract 25, 5 from 25, you get 20. This is our breadth. Okay. Now we need to know the height. The total height is 110. If 5 is gone here, a 5 is gone here, 5 is gone here, 5 is gone here. So 4 times 5 centimeter is to be subtracted from the total. So you get 110 minus 20, which is 90. This 90 centimeter is equally divided between how many cuboids? We have got 3 shelves, so 3 cuboids by 3. So you get 30. So my height is 30. I have got all the dimensions of the cuboid. Now I need to find out the area. Now, in order to find out the area of the cuboid, I need to keep in mind that the shelf is an open shelf. So the front face area, I don't have to take into account at all. So let us calculate the remaining area from the data that is given to us. I have got 2 walls. So this is L and this is B and this is H. Okay. So I have got 2 BH is there. Okay. I have got the top face which is, and I have got the bottom face which is L into B. So I have got LB, okay, plus I have got the back face which is L into H. Let us put the values and see what we are getting. So here you can see that I have written down the area separately just like in the previous case. The cuboid, the top face and the bottom face, it is 2 into 75 into 20. The back face which is this particular face, the area is 75 into 30. The result I am taking only once because the front face it's an open shelf. So the area we don't have to take. Now the side face which is this face and this face, it is 1200. I am adding up total. So I am getting 6450. This is the area of one shelf. I have got how many shelves? I have got 3 shelves. So I multiply by 3 in order to get the total area is 19350. Now the cost of painting is 10 pies per centimeter square. I multiply it by 10 in order to get 193500 pies, which is 1935 rupees. This is the cost for painting. Now what do we need to find? We need to find the total cost for painting as well as polishing. For polishing we have already gotten the total cost. Add it to this cost in order to get the total cost. Now I hope you are having a very clear idea about how to segregate the area and how to reduce the thickness and how to discount for open shelves or open rooms, etc. Okay. So now it is time for us to move on to the volume of a cube and cuboid. So if you have any doubts regarding this particular concept, mail me at the mail ID given below in the description box.